Right.
Yeah. So yeah. So we are doing a series of fireside chats, like industry experts like you, where we want to bring in the perspective of quality assurance and then what's automation they should be doing and should not be doing.
Okay.
So one of the topics that we are trying to take and discuss with you today is how does the shift left and shift the approaches, right? So how do you approach your test automation? Where do we start, and how do we what are the new trends that are coming in? So I have a few questions that we want to know from your views, and so that we can educate the upcoming engineers market.
Great, thank you.
Yeah. My first question is with what is shift left testing? If you can just give me a little brief, what is your understanding of a shift left testing?
But shift left testing, my understanding of it and the way I interpret it is that you're trying to test as early as possible within the project. So you're seeing the whole development process moving from left to right, with the right hand features in production, left hand it's just an idea, and you're trying to move your testing as close as just being that up to that idea as possible. But the basis of that is that the earlier you find a bug, the cheaper and easier it is to fix. If you've got a bug in production, well, actually, a customer's seen it. You don't know what that costs. That can be really expensive, but you actually can't quantify it. And actually, what you can quantify is that a developer's got to stop what they're doing. They've got to fix it. They've got to test it. They've got to deploy it. And that costs money. But if you're at the other end of that, if you shift all the way left, if you're just discussing an idea with product owner, maybe, and between you can identify some things that might become problems before it goes in production, and those can be addressed while you're just talking about it. Well, that costs 5 minutes conversation. It costs virtually nothing. So actually shifting your testing as far left as possible is something that will save the company money and will actually produce better quality products for your customers, and hopefully help the company grow.
Thank you for that. So moving on, so just want to understand what type of projects must adapt for shift left test automation?
Well, shift left, I'd be interested in what type of projects shouldn't you be using shift left testing, you know? Automation's got a role in that you want to have regression tests so that the developer can find out as early as possible if they've broken something. And it also has a role in when the new feature is created, you want to create a test for it to add it to your regression pack. But I'm interested in what projects shouldn't or wouldn't benefit from it, because actually shift left is actually about building quality in, rather than actually trying to test it in at the end. You know, if you try to test quality in at the end, well, actually the quality is already there. You know, the tester won't find all the bugs. Some of them will go into production. If actually you've shifted left and you've tried to build quality in, then in fact you're going to be in a much better place with much better quality software, as I say, and it'll be much cheaper for you. But yeah, I mentioned to you before this chat, my big inspiration is W. Edwards Deming, management scientist. And he talked about this in the 1950s. And his example of it was that he went to a Japanese factory because he was part of the American administration that was rebuilding the Japanese economy after World War II. And so he went to a Japanese factory and he saw that they had a number of production lines. And at the end of each production line, there was an inspector who was inspecting the quality and trying to inspect quality in. And if the products failed inspection, they went to another production line called rework, where the product was reworked before being inspected again. And when Deming saw this factory, he said to the factory manager, "What percentage of your staff work on the rework production line?" And the factory manager said it was 21%. And so he said, well, the next question was, if 21% of your staff are working on the rework production line, reworking products that have failed inspection, would it be fair to assume that another 21% of your staff were making production products that were going to fail inspection? And the manager said yes. So that factory was trying to inspect quality in, and it had 42% of its staff either making or fixing substandard products. But actually what Deming suggested was, instead of inspecting quality in, they should remove all the inspectors from the end of the production line, and instead define operational definitions at each stage of production, saying what was required, so that each stage of production quality would be built in. That way they could remove the inspectors and they wouldn't need a reworked production line. So they could improve their quality. And actually, because they'd improved their quality, they could improve their productivity, because there was no reworked production line anymore. And because they could improve their productivity, they could improve their costs. So actually, that can be described as shift left testing. This is going back to the grandfather of quality. And it shows how shift left testing benefits quality, it benefits productivity, and because of those, it benefits costs.
Yeah, that's very, very well articulated with an example what you gave. I think it's very easy to people to understand what is that shift left testing.
Yeah.
So now coming to the next question, right? So it's also now for every good thing there is also a bad thing attached to it.
Yeah.
So what do you see in your ways? How do we say that? What are the pros and cons of shift left testing? So if we can give a little brief on that. So what should do's and don'ts?
I'd say that the pros are quite clear. I think we've just spoken about that, because you can improve quality, productivity, and costs. I'd say the cons are actually culture and change management. If you come into an environment where the managers aren't aware of what shift left testing is, aren't aware of the ideas of building in quality, then in fact you've got to manage them and persuade them to engage with this, what for them is a new idea. And I think that's the real difficulty, because people can be really defensive, they can be really negative for a whole range of reasons. So I would say that I think is the real difficulty with it. And I think this is the issue of change management.
Yeah, that is, yeah. And also I think to add to that, I think the shift left testing is only efficient when you, as you given in your example, to define those quality checks at every stage. If you don't define those goals appropriately, then again, then that's not sufficient checks, right, at the early on.
Yeah, I think these operational definitions are really very useful, because what Deming is talking about is that you can't test an adjective. So if something is defined as being better or faster or more robust or more usable, you can't test that. What actually you need is something that's defined in terms of criteria and test. So this idea you would be taking into your planning meetings, which is shifting your testing left into planning, because it's far cheaper and better to find an issue in planning or find something that's a bit imprecise. The adjective is being used. I often look for adjectives. It's better, it's faster, something like that. And if an adjective is being used as a tester, you want to say, actually, what does this mean? You know, and this is one of the ways of shifting left. So I think this is an important sort of practical tool for us, these operational definitions.
Yeah. Moving on, so in today's world, I think most of the teams are talking about test ops. It became one of the buzzword in the testing industry. So can you just brief a little bit what it is, what is the advantages of it?
Well, I think it's one of those phrases actually that has different meanings to different people. And so in that way, it's quite hard to talk about it. Some of the things I've seen written about it define testing in very much in a waterfall style, without any shift left involvement. You know, you're given something to test, you test it, you find some bugs, it comes back for you to test what the bugs are fixed, and then it goes to production. And that's what testing is. Well, actually, I think testing is much more than that. And I think that some of people's models for testing are quite restricted, and they should engage with which are actually very old ideas about building quality in, designing quality in, and to get an understanding of a cycle of development. So I think those are things one thing I would say about it. Other things about it is it seems to me that it involves a certain amount of good practice in terms that as a tester, you haven't just got that narrow role. As a tester, you're going to be concerned with the CI pipeline. The CI pipeline is an important tool for managing quality, so that you are going to want an engagement with it. It's just one of the things they talk about. And I guess that's the ops side and the deployments. These are things that you want to be involved in. At the moment, I've just been creating some tests for a test framework for our API that's going to be included in our CI. So I think this would sort of fall into that sort of space. And I would say so that saying people should get those new skills is a good thing. I think to me it also falls into this idea of what is testing, because what should we be called? Because it's what is a tester? Because we don't just exercise manual tests. We do some automation. We'll write some scripts. We'll be concerned with CI. We'll be asking questions in planning. So there's quite a range of things that we do. So I'd say that there's some really good ideas in there that reflect good practice, but I'm a bit concerned that some of the models I've seen have a narrow sort of waterfall type idea of what testing is. What do you think?
Well, TestOps is very essential today. I think, as is going back to your example that in the Japanese thing, right? So again, when the whole process itself is automated, why not the last execution part? Right? So you have to automate that part as well as much as you can, so that you just get the benefit of it and you get an immediate execution results and feedback is what we want. So it has to be all integrated so that your automation should continue from your execution to the execution to. So again, I mean, like once you build the automation, again, why should you deploy it into the connected dots, right? So in my opinion, I think the TestOps is containing, one is your execution platforms, right? Your test lab is completely has to be virtualized. You have to integrate it into your CI/CD pipelines and all those things. And the next step is also it has to be ready for your integrations. Like you have to reporting platforms, right? So you have to report the issues back into your Zero, so the developer gets the issue directly. So that's the extent of the automation, and then the TestOps covers that part of it where you just give it back, right? The operation side of it. Once the automation is built, and now you're giving it back to the people to execute and start using it. And that's where it has to blend in with all the software lifecycle development of all the needs there. So you can integrate into your Jira, into your Teams or Slack, just to get instant feedbacks, so that you can immediately run those scripts and do the necessary corrections if required.
Yeah, because something I liked when I read about it was actually communicating what you're doing as a test team. And I have to say, I work for Geckoboard. We produce help companies share information in the form of dashboards, and some of them were talking about producing test dashboards. And so actually, that's something that you could use Geckoboard for as well. So that would be something that I very much appreciate about TestOps.
Yeah. Absolutely. Right. Moving on, I think let's go with the C. So one of the key important factor of this whole test automation is your test data. I mean, the best practice, everyone says, okay, don't put too much of logic in your automation scripts. Let's drive with the data. So doing a data-driven automation is one of the best ways of implementing automation.
Okay.
So what is the best practices you would say in the test data management?
That's an interesting thing to say. I mean, I like the idea that your tool does this data-driven testing. I think it's a really good way to work because you can create tests which run with different types of data, and you've got less code to manage because it's basically the same test running with different data. So I think that's really positive. I think for me that the important thing is that you've got it saved somewhere with your test data, that it's shareable, that everybody else has got access to it, so that way it's transparent. there are other things that are going to be context specific. For me in testing Geckoboard, it's very important that I have data that keeps updating. And so actually being able to create a node app, say, to create some test data, which is constantly running, so it's got new data with current date in it, is actually very important as well. But actually different people are going to find themselves in different contexts. And so I would say that doesn't apply everywhere. It didn't apply on other tools that I've tested. The data would have been static. So I think it's important that it's available to everybody, and that you're transparent. And then you've got to think about your own context. I think that's really important.
Absolutely. Yeah, it's one of the important feature for our product is also something called context parameters. So most of the data what we define is defined. Not every data set has to be fixed. So some data points will be relative data points. So rather than giving an absolute, let's say for example, I'm testing eligibility of a person for an insurance policy, for example. So typically you will be checking the boundary values of your the age limits, for example.
Right. Okay.
If you give a data which is rigid, then obviously after run the same test after a month, then obviously they're out of sync. So parameter is test data, and then we have a concept of test parameters / context parameters, where at the time of execution you inject the parameters into the test data, and the test data automatically transforms it to the current context. So that way, we have a motive saying once you create the test data, it should never expire. There's no expiry date for your test data, meaning so it should be able to use it whenever you want. And say if I'm saying is the person above 60 years, that's my eligibility criteria, then that should always say that. If I keep changing every month, then there is no point in doing that automation or the test data preparation. So my tips is like always don't keep it an absolute hard coded data, make it relative, so that you can the context should drive the test data to what it should be. So that way you are not disturbing the data. You're not going to keep fiddling it and keep working on the data again and again. And as you also said, the visibility is one important thing, and that's where most of the times I think teams create their own silos of databases, data sets, and then says it's all works on my machine, but it's not working on when we deploy it. So we heard that. Obviously, there is a lot of, especially working in larger teams, and this becomes more and more complex because it's not just one test that you're running thousands of tests. So there's a lot of moving parts there. So to keep that, I think you should have everything synchronized, and do everything as I rightly said, the visibility of the data, who is changing and who is not changing, how often it's changing. It all matters at the end of the day. Right.
Thank you.
Thank you. Moving on, I think my next question from my side is, so we see that we don't see these, well, with your philosophy now with the Deming's philosophy, that's one thing, right? So we never heard in QA world, I have 20 plus years of experience in the IT industry. We always talk about there's a design patterns, or there's techniques, or automation patterns, or you talk about the models that you try implement these things. The first time I think I'm hearing from you a philosophy that inspires you, right? Inspires you be something else. That's very, I never heard of it, but would like to know from you and a few lines about what is this philosophy of Mr. W. Edward Deming's philosophy, and what inspired you to become follow this philosophy.
Okay, so I became interested in WMH Deming when I was test lead in a startup in North London, and we went through an agile transformation. We moved from making monthly releases to doing continuous delivery. We made a startup towards microservices and continuous deployment as well. And during that transformation, we decided to read a lot to find out what lean and agile were and try and learn from what other people had done. And I found that virtually every book that I read about Scrum, Agile, Kanban, Lean, DevOps mentions this guy Deming. And so I thought, okay, I should read something more about him because everybody's quoting him. He's obviously, he has something very special. And what I found about him was that he was so involved with the American administration of Japan after World War II. And he said to Japanese industry, their philosophy should be quality. Japan has no oil, no coal, no gas. At that time, it had no timber after the war. Its cities and ports had been ravaged, and it had a reputation for shoddy goods. And at his first lectures in 1950, people like the founders of Sony came to hear him speak. He was a big influence on Toyota, and the Toyota production system was renamed by the Americans as Lean. So actually, he had a big influence on Lean. When I read, we had 2 Scrum teams. When I read about Jeff Sutherland's book about Scrum, he said the Deming cycle is how Scrum is done. So if you work in a Scrum team, you're using Deming's ideas. Deming said that engineers should work in a cycle where they plan what they're going to do, they do it, then they study what they have done, and then they take actions based on those studies, and they carry those actions through to the next planning meeting, and this cycle rolls forward. This is very practical and very philosophical. And if we're working like that, we can be working towards continuous improvement. This is what he was talking about, continuous improvement of quality. And as you work through the cycle, the team will get a better understanding of what quality is for them and their responsibility for quality. And this is sort of what appeals to me, that actually getting a better understanding of quality and my responsibility for it, and my colleagues' responsibility for it. Because if you understand quality well, you understand your responsibility for it, you can start adapting your testing, your engineering practices to improve quality. And these ideas of continual improvement of working in these cycles is really very, very useful. The cycle is also part of the Toyota production system, so it feeds into Lean. Jeff Sutherland said that the check part of the cycle, the retrospectives, and it's very important to move the team on to the act part so you get actions out of your retrospectives. So actually, it's a very interesting underlying philosophy that in fact, most of the people who work in software development are using in some way or another. And actually getting a better understanding of it, I think helps us produce better quality work and work well in teams. So that's sort of what appeals to me about it.
Yeah, I think so. What you're saying is like for all these agile, lean, and all are part of that that book you're talking about, right? So yeah. So now know that those kind of things. Now these things have become new, methodologies or practices. People talk it. Yeah, but yeah, there's a lot of history for all these things, I guess.
Yeah, that's right.
So can you just give us a little brief on in terms of what inspired you to be there? I mean, like you read those books, but what is that one factor that if a young crowd has to be influenced by Mr. Demings? So what is that you will say? Okay.
What inspired me out of it?
Yeah.
Yeah. Okay. I'd say that actually what really motivates me to talk about it, I've spoken at quite a number of events about Deming, and what's motivated me to do that is that if you're working in a team that doesn't understand the Deming cycle, this plan, do, study, act cycle, that doesn't understand the concept of building quality in and the benefits of that, then in fact, you're going to find it far harder to produce good quality work. And in my experience, the tester frequently gets blamed when there's bad quality work. There's a manager somewhere who will say, why did the tester not find that bug? It's the wrong question.
Yeah.
The right questions are, why didn't you build quality in? Why aren't you learning? Why aren't you on a path of continuous improvement? So I feel that if I can share that knowledge, then in fact, it'll help people produce better quality work. And I also hope it'll help my fellow testers, because people won't be saying, why didn't you find that bug? They'll be saying, why didn't we build quality in?
Yeah, makes sense. Yeah, perfect. Right way of putting it out. Yeah, it's not always the QA engineer's job. It's the management to put that QA first. Most of the times today, I think the QA comes the last bit. and they are not considered as important as a developer is. But in fact, the QA engineers has a very important role. I mean, throughout my life, I have seen it more as a developer. I see and I see that yeah, well, okay, I'm doing a lot of development, and because of that, my product is whatever the work I'm doing is going to the production. But in fact, I think the QA plays a hugely different role altogether, which may not be directly say, okay, I didn't build this page. I mean, he can never claim that he built this page, but the effort, because he's the main reason, the QA engineer is the main reason why people are using the system. If QA engineer is not there, I mean, who is going to look at the developer's work? I mean, only because it's been robust enough for the people to use, and that's where the systems will be successful. So QA engineers will not be directly seen, but yeah, they have a lot of a bigger role to play.
Yeah, I think it's an important role in partnership with developers to produce good quality work. We work together as a team, and that way we can produce quality work. It's not a case of, it shouldn't be a case of either side trying to catch the other one out. It's actually really about you working together. And I think that's really important. And I think if you do work together, you can produce very good quality work. That's my experience.
Fantastic. Yeah. Yeah. I think we are almost out of time, I think. Yeah. Thank you very much, Mike, for your time. Really appreciate discussing all these things with you. So hopefully my listeners will also, I particularly like your thoughts, and especially Mr. Edward Deming's philosophies. I think I have to go and read a couple of books to understand more on those things. I'll get knowledgeable on this thing, so that I can share to the next generation.
Great, thank you.
Thank you.
Very nice talking to you as well. Very interesting. Very nice to hear about your products as well.
Thank you very much.
Thank you. That's right. Thank you. Right, have a good day.
Thank you.
Thank you. Bye.